Aeolian processes on the surface of Mars. First up, wind mechanics. The robotic orbiter Mariner 9 entered the Martian orbit on November 14th of 1971. A planet-wide dust storm was raging at the time throughout the entire planet. This dust storm had started some 2 months earlier and was detected from Earth-based observations. Through a telescope, the Martian dust storm appeared as a yellowish cloud eventually covering the entire planet at a rapid pace. This dust storm was one of the earliest pieces of evidence that Aeolian processes were operating on the Martian surface. Martian dust storms are one of the few geological processes that remains as an active event right up to the present time. With Mars having a smaller surface gravity and a lower atmospheric pressure, very large wind speeds are necessary to move dust particles and transport them across the planet. Typical wind speeds in the Martian atmosphere exceed 125 miles an hour. Wind gusts can often reach 300 to 375 miles an hour. The average mean wind speeds at the surface during a dust storm are typically about 67.5 miles an hour. With wind speeds as high as they occur on the surface of Mars, the Martian dust particles can be blown off the surface of the planet on a global scale, producing dust storms that can be observed through a telescope all the way from Earth. When it comes to the subject of Martian impact craters, they are often found to be not as pristine and sharp on their edges due to the wind mechanics of degrading and erosional effects of particles suspended in the blowing atmosphere. Number 2, wind deposition. Wind deposition on the Martian surface also occurs quite frequently. At the landing site of the Viking 2 lander probe, images were taken of a thin coating of a dust layer mixed with water ice on all the rocks in the area. This represented the deposition of dust particles from the atmosphere on the Martian surface. As the Martian atmosphere changed to its colder winter season climate, water and carbon dioxide started to condense upon dust particles suspended in the atmosphere. This condensation increased the weight of the dust particles and caused them to settle onto the ground. The carbon dioxide ice, warmed up by the sun during the day, vaporizes rapidly, leaving the dust and water ice on the surface for about 100 days out of the Martian year before a warmer spring to summer climate returns, causing the water to vaporize and dust particles to be blown off the ground and suspended in the atmosphere once again for yet another cycle of Martian Aeolian processes. Number 3, wind streaks. Wind streaks on the surface of Mars are some of the most prominent Aeolian features on the planet's surface. They are tear-shaped features deposited by the Martian winds behind craters, ridges, or cliffs. Being that these features are the result of wind erosion and deposition, they may appear light-colored or dark-colored depending on the nature of the surface and subsurface particles that they were extracted from. Also, with wind erosion occurring behind some obstacles with strong wind coverage to sweep away fine particles, lava plains are exposed from underneath, resulting in dark streaks. Some geological obstacles on the Martian surface might create what is known as a wind shadow, where wind speeds have died down, creating an environment for deposition of suspended particles. Number 4, sand dunes. Sand dunes are very common on the Martian surface. Smaller scale Martian sand dunes are capable of occurring in small areas such as inside craters and valley floors. The Mars Global Surveyor was able to obtain high-resolution images of Barkhan dune fields. The Barkhan dune is a sand dune that is crescent-shaped, and transverse dune fields. Transverse dune is a sand dune with a wavy ridge running along their length, and linear dune fields. Linear dunes are shaped like ripple marks on a sandy beach. Also, the lack of craters within a dune field is an indication that the dune field must be geologically young. Lastly, yardangs. Yardangs are a geological feature that resemble inverted keels of sailboats that are arranged parallel to each other. The parallel ridges are created by wind erosion. Many of the yardangs on Mars occur in the heavily cratered southern highlands by repeated wind erosion and depositional processes. Thank you for watching, and I hope you've liked this video on aeolian processes on the surface of Mars.